Hello and welcome to the section on documents in meilisearch. Here are a few things you should know before the demo. A document is made of fields. So just to show you what it is all about, here you go. ID and 2, each of it forms a field. A key value pair forms a field. Now getting back to the presentation, each field is a key value pair. We just saw that. Documents have a soft maximum of 1000 fields. That is, ranking rules can stop working and we can observe undefined behavior if there are more than 1000 fields. There can be at most 65,536 fields per document. Each document should have a primary key. Remember, we talked about primary key in the section about indexes. A document can be added, updated, or deleted from an index. An index is a table. An update refers to either updating a bunch of fields or replacing a document. We'll see a demo of both. A document can be added to an index in CSV, JSON, or ND-JSON formats. Again, we covered these formats briefly in earlier videos. One thing to remember is adding documents to an index is RAM intensive, so profile your server instance before production deployment. Welcome to the demo section. We're going to first look at the code and then run it to see the demo of it. To start with, remember to export two environment variables, host and master key, as shown here. We're going to cover a new library called Takadem. This is a progress indicator that can be used to observe the liveliness of your system. That's about it. So let's get on with it. The first method that we're going to look at is called createIndex. This should be familiar from your previous videos, but here we go. We call client.createIndex with the index name, and we set ID as a primary key. If the index already exists, or if the index succeeds, then we return the index. If not, we'll raise an error. Here's the calling code. We create a config with the host and master key as parameters, a client, and then call createIndex. Here's what you've been all waiting for: add documents to index. This method is responsible for adding rows to your index or documents to your index. So here we open the file movies.json that we saw a few minutes back, and we iterate through the JSON contents. Here's how you use Takadem. You can wrap any iterable with Takadem and it will show you a progress indicator. So here we start iterating in terms of batches. The reason for using batches is that meilisearch restricts payload to a limit of 100 megs. So we go ahead and batch it internally. Then we call add documents method. Remember that each document has a primary key field. So after adding every batch of say 1000 documents, we check for the status. Remember, an asynchronous API. That's the construct that we follow here. We wait to see that the task is complete, and hopefully it should succeed. If not, we print the status information to the console. Let's now see a demo of adding documents. So see here we get the index stats. So you can call index.getStats to see the number of documents that the index currently holds. See this progress indicator? This is where Takadem comes in. It can be used alongside any iterable, and it will show the progress of the total number of iterations across the current iteration. Let's just wait a minute and this should be over soon. there you have it. 31,944 documents have been added to the index successfully, starting from 0. Given that we have now added documents, let's see a helper function to retrieve a document. We will dive into a lot of detail when it comes to querying documents, because that is the meat of an information retrieval system. For now, let's just use the snippet to get a flavor of how retrieval works. We use the index that we created earlier, remember, through create index. So here is how we created the index. We use the same index instance and invoke the search method with query containing the string that we want to look up and optional parameters which can contain things like offset, limit, etc. Here we limit our result to just one document. This result, the documents returned by index.search is an array of documents inside the hits key. We can iterate through it and print it as shown here, and that's what we'll see upon running this method. So see here, we need to look at the next operation, which is replacing a document. So let's first see what this is about. We retrieved one document earlier using the getDocuments API, rather the helper function which invoked the corresponding API. Now we go ahead and set certain fields like title, genre, and overview. So this one will actually replace the existing document. That is, since the ID will match that of what we are searching for, the original fields will be erased and only these fields will exist. So the fields like release date and so on will be removed. So let's see the demo. So if you look here, before replace, it contained title, Arial, then overview, and then genre, poster, and release date. Now it contains title, overview, and genre with the array that we provided. So that's what replace is used to do. Remember that other than the ID field, every other field is optional. Again, we use the same add documents API. Since we provide the ID, it's a replace operation. If it exists, if not, it will just be added to the index. Since this is an asynchronous API, we wait for the task to be completed, and that's what this snippet is all about. Turning our attention to the update functionality. So before update, we get the document, and remember that during replace, we change the genre, the title and overview remain the same. But now we're just creating an array for update. So we use the same document ID and then call index.updateDocuments. So since the ID matches, we go ahead and change the title from Arial to the Arial. See here that we have specified just the field that we want to update, or it can basically be one or more fields that we want to update, but the rest of the fields are going to remain the same. They won't be overwritten. So that's why the update behavior is controlled by the actual field values that are being updated. That's the difference between replace and update. Again, this is the title before update and this is the title after update. We saw, although we provided just the title, other fields remain intact. Now comes the last part. We first select the ID of the document to be deleted, and then we invoke the delete document API of the index object. Again, as always, we check for the status since there's an asynchronous API, and see here the results. Since we invoke delete on a document of ID 2, it's no longer present when we search for it. So there you have it, folks. That's the end of create, read, update, and delete operations at document level. One thing that we will dive deeper moving forward is the retrieval part, that is the read portion, which is what makes an information retrieval system really useful.